Hello. Hello, hello, hello. How's everyone doing? Good lunch? Excellent. So I want to start off real quickly talking about some of the apps that we see nowadays. So let's, for example, think about smooth streaming players, or thinking about things like to-do MVC, rock my talk, or to think about code editors, or games, or even Netflix, or even things such as advanced business intelligence, to other more games, and to even things like productivity such as drawing. What do they all have in common? Well, they're all basically reactive-based applications. So what we're going to do is we're going to dive deep into exactly that. What exactly makes a reactive programming program interesting? So now let's go back to the real talk at hand here. So we're going to be talking about how reactive programming has really kind of changed the world and the way you create apps today. So of course I always want to start off with a little bit of JavaScript just to get everybody warmed up. So you know what this, sup? And since this is all about concurrency, let's just go there and just say, take me down to the concurrency city where green grass is, the girls and the and are. It happens. So you may wonder why I wear this stupid hat. So I am a principal software engineer and open sorcerer, as it were. And the reason why I called myself that was because I worked on a lot of things at my company where I truly believe that they had a lot of influence. Things like early adoption of Node on Windows, talking about early F# adoption, including reactive extensions. But also recently, we released React Windows, which is the React Native for the UWP platform that I currently work on. So I'm from, you might be thinking it's kind of strange. Here's a Microsoft guy with a Mac up here talking at an Angular conference, but here we are. So I'd like to think that I put a little bit of metal back into Microsoft with all the stuff that I do. So primarily, I work on what's called the reactive extensions. How many people have heard of that? Anyone? Anyone? All right, a few people. Hey, and some applause. There you go. So I would easily say that I'm an RX pusher. And what I'm trying to do is trying to relay how exactly reactive programming is really, really an interesting paradigm, especially for us in the JavaScript world. Primarily what I want to talk about as well is people that are using it today. So Netflix, obviously their idea is that they want to stream movies and TV shows from any device. And currently they could be a third, they might be more of the US broadband traffic right now. So how do you deal with something like that? Something that big a scale? Well, you really have to do that. You have to think really, really different. So this is the story of how Microsoft, Netflix, and others solve some really big async problems by thinking quite differently about how we think about events. So when you think about the Netflix player and you think about other things such as Microsoft Delve, you think about any number of things, everything about your apps today is asynchronous, whether it's your startup, your player, your data access, your animations, view model bindings, everything about your app happens to be reactive in some form or fashion, or at least event-driven. But what comes with that comes a number of things, such as nightmares that you had to deal with. Memory leaks. I forgot to get rid of my event handlers. I left a few open. I have race conditions between certain events that are happening. I have callback hell. You know, complex state machines, whether I don't know quite how to read where my code goes next. And so you have all this disjointed error handling because of that, because you now have error handling in 5 or 6 different places. So when Netflix really started this, they had a thing where they had 5 or 6 different languages where they were going about and trying to solve asynchronous problems in different ways. It wasn't until they discovered something like the reactive extensions that it suddenly popped a light for them that they realized that they could write their entire set of applications using one kind of language, as it were, which is the reactive extensions, which is actually language neutral. There's RX Java, there's RX.NET, there's RX Groovy, Python, Ruby, Rust, you name it, and of course JavaScript, you name it, there are versions for that. So what they're able to do then is they're able to switch people between layers, but they're still speaking the same language. They're still speaking RX. So let's just face a certain thing. Asynchronous programming as we know it today is awful. You know, we live in callback hell, and it's not just because we're too lazy to do you know, continuation passing style and just having the code walk off the page. It's more along the lines of we also have this really complex state machines as to where we're actually handling errors, where we have success conditions, and so forth. And what you end up with is a cow's head. But I think it's even worse when you're dealing with events. You know, so something as simple as doing drag and drop is actually a lot more lines than you think it is. Because not only do you have to track mouse down, mouse up, and mouse move, but you also have to track the state in between. So what you always end up with a lot of the times is this poor kid trying to get the data after it's long gone. Poor kid. So promises are great, but they're only part of a solution in the fact that I can now linearize that callback hell that I had before. So I can initialize the player, then authorize the movie and handle the login error if there is one, and then I can play the movie or else it's unauthorized. But that's a great part of why promises are now very useful, is the fact that we now have a single value to represent single async values. But there are problems with that. For example, there is no innate way in the promises spec itself to handle cancellation at all. So, for example, in the fetch API, that's part of service workers and so forth, has no way at all of doing canceling a promise. And in fact, there's a wide array of discussion about this, and if you take a look at this thread, there are 21 participants and 204 comments. So you could ask yourself, how many engineers does it take to cancel a promise? Sorry. But not only that, but there was also certain things that were missing from the spec as well, and the fact that there is no finalization as well. So if you're trying to model something such as I/O, which very much has a notion of cleanup at the very end, as well as any cancellation, like you get halfway through uploading a file and you want to stop, well, then promises as specified today do not have that solution. I hope in the future that they will. And that's all I'll really say is I would really, really like to see it happen. So it really is the final countdown in the fact that it doesn't have it. So one of the most common things that people try and do and to explain is why it's interesting. How many people have implemented type-ahead search? How many people have done it right? How many people have done it under 200 lines of code? Wow, a few people here, brave souls. So I did it in jQuery just to show you how it's done, and I did cheat just a little bit in using ES6 syntax here, but you can tell there's a way to call the JQXHR, there's a way of debouncing, there's a way of retrying if there are failures, etc., etc. So it's write more, do less. Let me ask you, can we do better? Well, I think so, because it really is a national priority of ours. Even back in the 1960s, when we choose to solve asynchronous programming and do other things, not because they're easy, but because they're hard. But then he soon realized that was not really the case, and it was easier just to go to the moon. I think. Anyways, so callback hell we can actually solve in a very reactive way instead. So when we think about flat map or something like that, we're really talking about chaining one observable or one continuation to another. So don't really think too hard about it just yet. But the idea here is that we're initializing it, taking the player attempts with the movie ID, authorizing it, trying it 3 times, and then take until cancel. So for example, halfway through, and it's taking a really long time on my network, I can hit the cancel button. Suddenly it goes away. Everything in terms of its initialization and everything else just goes away. Now the same thing with that mouse drag example that I showed before, where we had certain things with showing mouse drags. Well, here we combine the flat map with, we take the mouse down and the mouse move until mouse up. That was simple. And even type ahead, where I showed you really hard code, was really just getting the value, debouncing it just a little bit, so if I'm a really fast typer, and not only that, but I also handle out of order requests that come back, and then I can retry 3 times. So what you'll find is it's really actually harder to get burned that way. So much better. So what is reactive programming exactly? No, it ain't this. Nope, not this either. So what it is if we want to go to the dictionary, it says readily responding to a stimulus. Okay, well, we've been doing that for a while. Isn't it more than that? You know, because us hipsters, you know, well, those with us with beards who have been doing reactive programming for a long time said, yes, you kids, we've been doing this for a long time. But you really want to know what it is, you can go ahead and read a paper, but you know, just be prepared that most papers leave you kind of somewhere like this, and I understand that. You know, even the most brightest of us have those kinds of reactions when we're looking at academic stuff, and those industrious Germans really do have a word for it. So what else really makes up reactive programming? I would certainly say react to load, obviously. You know, when do you start shoving things down your shirt is certainly one of those things. React to failure as well. You know, when do you bail out? And how do you react to your users without giving them the beach ball of doom? So back in 1994, I don't know how many people were born back then, but there was this book of the Gang of Four. And iterator and observable were 2 of those patterns, but they were never connected. But let me ask you this. What is the difference between an iterable, what we see here, of just simple coordinates, and an event? And I'd like to say that absolutely nothing. They're both collections of some sorts. Arrays are simply collections in memory, and events are collections over time. That's it. So we already have the iterator pattern in ES 2015 where we can call .next, and it gives us whether its value has a value or it's going to next, and then finally you get true. And the same applies to what we've always been doing in JavaScript as well, with DOM add event listener when things go. But right now what it is pull versus push. This add event listener tells us when it's ready, it will give us things. So it's really the, what I would say is the subject observer pattern that they had, but done right. So what we have is the observable here with a subscribe, and that subscribe takes in an observer. So that observer takes in, so it says, notify me when there's something next, when there's an error, and when there's a completion. And then I hand you back the subscription. That subscription then will allow us to unsubscribe at any point and clean up the entire chain. And we have a certain grammar to it in the way that it actually works, so that, for example, if we have a couple of values and infinite values, we keep going. We can keep going, we can end on errors, we can end on completion, but we can never have overlaps, and we can't have things happen after the fact. So now we have this notion of a first-class async value. Really kind of cool. You can create one, and you can return one from a method. So it's great for testability purposes. So when we think about where it fits, we've got object for single value synchronous and iterable for multiple value synchronous. Then we have the promise for asynchronous single value. But then we have observable. So observable, as you can see from iterable, is the same exact code. So you kind of realize, wow, everything really is a stream. So if you understand a few very small things with very small functions, you can understand a lot. Map projects one value to the next, so it doesn't mutate the existing collection, it creates a new collection. We can filter, so I can say I only want circles here. I can do the flat map. Well, that gets a little bit more difficult, but you can just think of it as a map, then a flatten into a single stream. So whatever you do, you must flat map it. So the future really is here. With Angular 2, a lot of things have started to become observables themselves. As you'll know, the HTTP module and so forth really became a core part of what of Angular. And what's really cool is we can take that same type of head search that we had before, turn it into an ng-form control with our async pipe, and then we can go ahead and do our search. Since search is nothing more than an observable, we can say get and then map. And then here, we can do our Wikipedia thing, which is value changes for that particular term or that control, distinct until change, and then switch map. Now we can also do more advanced things, such as video lists. So if you're imagining on a very constrained device, you only want to keep in certain things on the screen if you can help it. Now, I'm not going to necessarily dive through this, more along the lines of it's going to go through there and start to pull whether or not the actual frame or row is in sight. And if it isn't, then that take until row hides basically gets rid of it and all of the associated events and so forth with it. So it's really great for constrained devices as well, to make sure that you have nothing dangling. And even the Netflix player itself, when you take that callback hell, we had that what we showed before. Now, Slack for Windows, if those who actually use Windows around here, they have implementing spell check and a lot of other things as part of Slack. So once again, I'm not going to necessarily go through this, but I'm showing you the power that people do. So for example, when you're typing, and then when you stop typing, it's going to start figuring out what language you happen to be using, and not only that, but then starting to do suggestions based upon what you've typed, if you've typed in TEH and you meant THE. So NGRX, really, really cool stuff. Rob Wormold has done some really cool stuff there with Angular and so forth. How many people have heard of Redux? Good number of people. Okay, what if I told you it's only one line of code in RX? Scan. Yep, there it is, right there. Some say it's a two-liner using scan. It very well be, and it is. So once again, on the server, you've got the same kind of thing. You can do really advanced stuff, like I said, the React to users, React to everything else. I think it's very, very important for Node as well. What's also really cool is the fact that it's actually hopefully coming to become a standard as well, where we can start writing these instead of needing anything else. No frameworks or anything like that required. So with that, I would like to take off this hat for just a moment, and I really would like to make reactive great again. So we're going to go ahead and build a wall around all those non-reactive frameworks. It's going to be huge, and we're going to make Google pay for it. So, thank you very much.